Hello friends, so our today's question is tapping rainwater. So what is given in this question is we are given an non-negative integer representing an elevation map where the breadth of each bar is 1. Compute how much water it can tap after raining. Okay, so basically we are given the height of the bar and we need to find out that how much water it can tap after raining. So consider this example. So what is given in this example? We are given a bar okay, so 1, 2, 3, 4, and somewhere here 5. Okay, now we are given a bar. So first bar is of height 4, then second bar is of height 2, then third bar is of height 0, and fourth bar is of height 3. So let it be 3. Okay, again fifth bar is of height 2 and last bar is of height 5. Okay, so like we are given a bar of some length, okay, and the breadth of each bar is 1. So we need to find out that if it rains, that how much water it can accumulate. Okay, so we know that to accumulate a water in anything we need to have its boundaries set. So basically if we want to have water accumulated in a container, so it should have a boundaries. Okay, so in the same way, if we want to have water accumulated here, we need to set the boundaries, like yeah, between these two bar water can be accumulated. So how much water we can have here. Okay, so like in this way, because the okay, so if we consider this one now, this scenario, so water can be accumulated here, water can be accumulated here also, here also, here also. So like maximum water that we can accumulate here is the 4, like maximum height where we can accumulate the water is 4, because after 4 the water will fall out, where the we are having maximum length of a bar to 5, but we cannot store up till there because we need to have another bar to support that height. Okay, so that another bar, we are having height of that another bar as 4. Okay, so more than 4 units of height we cannot use because it will fall out of that. Okay, so like in this way, so here okay, so if we are considering these two boundaries, like this one and this one, first and last boundaries, yes, so what amount of water we can accumulate here, 2 units of water can be accumulated. Okay, here 4 units of water can be accumulated. Here the height is 3 and the maximum we can go here is 4. Okay, so here 1 unit of water can be accumulated, and here the height of this bar is 2 and the maximum that we can go is 4. Okay, so again we can accumulate here 2 units of water, so the whole water we can accumulate is 9 unit. Okay, so in this way, like okay, we are having a space between any bar. Okay, so we are first of all we are checking, like okay, so whether we are having a container or the bar of the same height, or the different height, or we are having a bar greater than the current height. Okay, if we are having if we suppose we are having this bar also of same height, so here we cannot also the this area would have been our main focus where water can accumulate. Okay, so like we have to find the for any particular index or any for particular column, we need to find the maximum height before it and the maximum height after it. Okay, so but the minimum, okay, so like for this case, okay, just just a second. Okay, so like for this one, if we consider this index, so for this we need to find the maximum height before it and the maximum height after this. So the maximum height before it is 4 and the maximum height after this is 5. Okay, but we cannot, as we have seen, like we cannot use the maximum of these two columns, because if you are going to have water after the length 4, it will fall out of that container. Okay, so we have to choose minimum between these two maximum heights. Okay, so 4 we have chosen. Now what is the current length of this current index? What is the length of this current index? It is 0. Okay, so here we have find out like 4 unit of water can be stored here. In the same way, like for this case, if we consider this case, so what is the maximum height before this bar is 4 and the maximum height after this bar is again 5. Okay, so minimum of these two is 4 and the current height of this bar is 2. Okay, so what maximum amount of water that we can store here is 2. So this unit can store 2 water. So in the same way, the example which is given here, so they have also illustrated in graphically. Okay, so they have given 0, 1, 0, the respective height of these bar, and the breadth of each bar is 1 unit. Okay, so that for waterfall, so we want to if we want to store water, then we want to have boundaries for that water to hold that water. Okay, so in the same way, like this can store 1 unit, this can store 4 unit, and this can store 1 unit, so overall 6 unit water can be stored in these height. Okay, so first of all, I think we have understood the question pretty well, and now we need to find the approach. So I think approach also we have cleared, like for to store water between any two bar, we need to find in any container, we need to find its boundaries, right? The maximum boundaries which can be there to store water in that. Okay, so like, okay, just a second. So we have seen, like, as in this case, if we want to have if we consider for this bar. Okay, so now we need to find the maximum height before this and the maximum height after this, where a water can be stored. So maximum height before this is 4, obviously 4. Okay, and the maximum height after this is 5. Okay, so we are having bar of 4 and 5 length, but as we have seen, like if we are going to fill water after 4 unit of length height, then it will fall out of this, so we have to choose the minimum between these two. Okay, so we will have 4 here. Now what is the current length of this bar? It is 2 units. Okay, so it is 2 units, so 4 can be total if no if the length of the bar is 0, so 4 units can be filled, but the current length of the bar is 2 units, so only 2 unit can be filled here. So this is the case, because 2 units can be filled here. So like this, we can find out for each bar how much unit water we can store, and then we can sum all those, and we will have our final answer. Okay, so here I am going to use dynamic approach to find the solution. Okay, so in this way, what I am going to use, what solution we are going to have is, now we will have two array of the same length as of height, left and right, and in these array we are going to store the maximum of the maximum from the of the current bar, maximum from the left, and from the current bar, maximum from the right, we are going to store in this. Then as we have seen, we will have the maximum from left and right, then we will have the minimum of those two. So from the minimum we will subtract what is the current length of the bar. Okay, so like in this way we will iterate. Okay, so like so basically, from for left maximum, we will start with the zeroth index, like the first column, and for the right one we will start with the last column, that is 5. Okay, so we will check for the current, we will start our iteration from here, and we will check what is the maximum. Maximum, is it the current bar is maximum, or the previously which we have in our left array is maximum? So it is not there, so 4 is the maximum here. Again 4 is the maximum bar, again 4 is the maximum, and for the 0 1 2 3 0 1 2 3 4 and 5. Okay, 5. For 2 also 4 is maximum, and for 5 is maximum. Okay, and for this one we will start from backward. Okay, so 5 we have stored in the last. We will check for 2, last one is 5 only, maximum is there. Okay, for 3 also 5 is only maximum. For 0 5 is maximum. For 2 5 is maximum, and for 4 5 is maximum. Now we have the, for particular height, we have its left maximum and we have its right maximum. Now we need to check between these two, for this, like okay, for this one column we have 4 as left maximum and 5 as right maximum, but we have to choose the minimum between these two. Okay, and then what is whatever the minimum, we have to subtract current height of the bar. Okay, so what we will do the same. So for between these two, what is the minimum is 4, and current height is 4 also, 0 again. Now for the second one, minimum is 4 and the current height is 2. Okay, so we will get 2 from here, 2 units can be stored in the second column. Again the minimum is 4 and current height is 0, so 4 units can be stored here again. So 4 is the minimum, from 4 3. So 1 unit can be stored here. In the same way 2 unit can be stored here, and from 5 0. Okay, so our sum is 9. So this is our required solution. Okay, now we are going to look to its implementation. Okay, so first of all we will have a variable, then we will have two vectors, let's say left, which we will raise to the same as the height, the size of the height. Okay, now okay, so what we have seen, we will initialize for the left. We will, as we are not having any on the right, and no bar on the right, and for the right we are not having any bar on the left, on the right side after that. So we will initialize these with the last and the first. Okay, so left of 0 is equals to height height of 0, and in the same way right of n minus 1 is equals to height of n minus 1. Okay, now we will iterate, and we will find first of all left. We will start from the first index. Okay, as we have already placed 0 I plus plus. Now we will check, we will store left of I is equals to maximum of currently, which is currently the height, height of the column, current height of the column, and what is previously we are having in left. Okay, so left of I minus 1. So in this we will get our left maximum for each column, and for right we will again iterate for int I is equals to I minus 2, I is greater than equals to 0, I minus minus. Okay, we will check, okay, right right of I is equals to maximum of right right of I plus 1 comma current height of I. Okay, so we will have right max. Now we have the left maximum and right maximum for particular column. Now what we need to do, we need to have the minimum of these two, left maximum, right maximum, and then we need to subtract it from the current height of the bar. Okay, so we will iterate, and we will have a sum, answer variable, or we can say int answer answer is equals to 0, and we need to return this answer. Okay, so we will return answer. Okay, so we will iterate int I is equals to 0, I is less than n, I plus plus. Okay, now what we will do, we will have, okay, so we will have, okay, ans answer plus is equals to minimum of left of I comma right of I minus current height of I. Okay, so this is what we have seen. Okay, so first we will run this code, whether it is accepted or wrong answer. Okay, minus 30. Okay, so we have done mistake here. It is not I minus 2, it is n minus 2. Now we will run this code. Yes, it is accepted. Now we will submit. Yes, it is submitted successfully. Okay, so what is the time complexity for this question, as we are iterating the height in a linear time? So its time complexity is capital O of n, where n is the height of this where n is the size of this height array. And for the space complexity, as we are using extra space, so we will its space complexity will space complexity will be capital O of n. Okay, so thank you for watching.